Welcome to sureshbhattclasses. We are solving questions on quantitative aptitude topic H.C.F and l.c.m. All the topics of quantitative aptitude are useful for many competitive exams like SSC CGL, RRB, Bank PO, Railways and many government job exams and job interviews. These topics are also useful for many entrance exams like GRE, GMAT, CAT, SAT, ACT and many more. Please watch all my videos on quantitative aptitude topics. In this video, we are going to solve questions on LCM. Our question is, what is the least number which when doubled is divisible by 15, 18, 21 and 24? The given options are option A 1890, option B 1260, option C 630, option D 2520. Before solving this question, I request you to please like, share and don't forget to subscribe this channel. We have to first find the LCM of 15, 18, 21 and 24 and then we will half that LCM and that will be our answer. We will first solve it by shortcut method. The largest number in given numbers is 24. The next largest number is 21. 21 is 7 times 3. 3 is included in 24. So we have only to multiply it by 7. So I will write multiplied by 7. Now 21 is included in 24 multiplied by 7. Now 18. 18 is 9 times 2. 2 is already included in 24. And in 9 is 3 times 3. 1 3 is included in 24 because 24 is 8 times 3. 1 3 is left over. So we will multiply this number by 3. Now 18 is completely included in 24 multiplied by 3. The next number is 15. 15 is 5 times 3. 3 is already included here. Only number left is 5. So we will multiply it by 5. And this is our LCM. 24 times 5 is 120. And 120 times 3 is 360. And 360 times 7 is 2520 and 2520 is the LCM of 15, 18, 21 and 24. This way we can easily find the LCM of given numbers. Now we will find the LCM by common division method so that you can understand both the method of finding LCM. We write all the numbers 15, 18, 21 and 24. We divide these numbers by 2. We write 15 as it is, as it's not divisible by 2. 2 divides 18 for 9 times. We write 21 as it is, as 21 is not divisible by 2. And 2 divides 24 for 12 times. Now no two numbers are divisible by 2. So we divide these numbers by 3. 3 divides 15 for 5 times. 3 divides 9 for 3 times. 3 divides 21 for 7 times. And 3 divides 12 for 4 times. Now all these numbers 5, 3, 7 and 4 are co-prime numbers. So we can directly calculate the LCM now by multiplying all these numbers. Then our LCM is 2 multiplied by 3 multiplied by 5 multiplied by 3 multiplied by 7 multiplied by 4. We keep aside 5 multiplied by 2 as 5 times 2 is 10 and we will add 1 0 after multiplying all remaining numbers. 3 times 3 is 9. 9 times 7 is 63. 63 times 4 is 252 and 252 multiplied by 10 is 2520. Now the required number is 2520 divided by 2 equal to 1260, and this is that least number which when doubled is divisible by 15, 18, 21 and 24. And from the given options our answer is option B, 1260. I hope you have understood the method of solving such type of questions. We go to the next question. Our question is, find the least number of 5 digits exactly divisible by 15, 18 and 21. The given options are option A, 10,062, option B, 10,059, option C, 10,065, option D, 10,080. Before solving this question, I request you to please like, share and subscribe to this channel. The least number of 5 digits is 10,000 and every option given to us is close to 10,000. Now we have to find our answer from the options. In the given numbers 15, 18 and 21, 18 is multiple of 9. So from the given options, the number must be divisible by 9. Option A, the sum of digits is 9. So option A is divisible by 9. In option B, the sum of digits is not divisible by 9 as sum of the digits is 15. Similar is the case with option C. The sum of the digits in option C is 12. And in option D, the sum of the digits is 9. So it is divisible by 9. Now we have to choose in between option A and option D. Option A cannot be our answer because it is not divisible by 15, as any number which is multiple of 15 must be ending with 5 or 0. So option A is not our answer. The only option left is option D, 1080, and that must be our answer. Now we'll solve it by proper method. We will find the LCM of 15, 18 and 21 and we will find the LCM by common division method. As all the numbers are divisible by 3, so we divide it by 3. 3 divides 15 for 5 times, 18 for 6 times and 21 for 7 times. Now all these numbers 5, 6 and 7 are co-prime numbers. Therefore we have to multiply all these numbers to find the LCM. LCM equal to 3 multiplied by 5 multiplied by 6 multiplied by 7. 7 times 6 is 42. 42 times 5 is 210. And 210 times 3 is 630. So our LCM is 630. Now we have to find the number which is least number of 5 digits divisible by 630. The least number of 5 digits is 10,000. Now we will divide this by 630. 630 divides 1000 for one time. On subtracting 630 from 1000 we get 370. We carry 1 0 from above. 630 divides 3700 for 5 times. 5 multiplied by 630 is 3150. On subtracting 3150 from 3700, the remainder is 550. Now our answer will be 10,000 plus 630 minus 550. As we have to subtract the remainder from 10,000 to get the number divisible by 630, and then we have to add 630 so that the number again becomes the 5-digit number, because after subtracting 550 from 10,000 the number will be of 4-digit number. and we have to make it a 5-digit least number divisible by 630. So we first subtract the remainder and then we add the LCM, or we add LCM and then subtract remainder. 630 minus 550 is 80, and 10,000 plus 80 is 10,080. And from the given options, our answer is option D, 10,080. I hope you have understood the method of solving such type of questions. We go to the next question. Our question is, find the greatest number of 4 digits exactly divisible by 25, 40, 60 and 75. The given options are option A, 9,200, option B, 8,800, option C, 9,600, option D, 9,400. Before solving, I request you to please like, share and subscribe to this channel. We will first find the LCM of 25, 40, 60 and 75. We first divide all these numbers by 2. We write 25 as it is because it's not divisible by 2. 2 divides 40 for 20 times, 60 for 30 times, and we write 75 as it is because it's not divisible by 2. We again divide these numbers by 2. We write 25 as it is. 2 divides 20 for 10 times, 30 for 15 times, and we write 75 as it is. Now two numbers are divisible by 3, so we divide it by 3. We write 25 as it is. We write 10 as it is because both these numbers are not divisible by 3. 3 divides 15 for 5 times and 75 for 25 times. Now we divide these numbers by 5. 5 divides 25 for 5 times, 10 for 2 times, 5 for 1 time and 25 for 5 times. We again divide it by 5. 5 divides 5 for 1 time. We write 2 as it is, 1 as it is, and 5 again divides 5 for 1 time. Now our LCM is 2 multiplied by 2 multiplied by 3 multiplied by 5 multiplied by 5 multiplied by 2. There are 2 5s and 3 2s. We take 2 2s and 2 5s. 2 5s multiplied by 2 2s are 100. Now the remaining numbers are 1, 3 and 1, 2. 3 times 2 is 6. 6 times 100 is 600. And 600 is our LCM. The largest number of 4 digits is 9,999. We divide this number by 600. 600 divides this number for 16 times, and 16 times 600 is 9,600. On subtracting 9,600 from 9,999, we get 399. This is less than 600. 9,999 minus 399 is 9,600, and this is that largest number exactly divisible by 25, 40, 60 and 75. And from the given options, our answer is option C, 9,600. I hope you have understood the method of solving such type of questions. We go to the next question. Our question is, what least number is to be added to 2,583 so that the sum is exactly divisible by 5, 6, 9 and 15. The given options are option A 27, option B 17, option C 37, option D 7. Before solving this question, I request you to please like, share and subscribe to this channel. We have to first find the LCM of 5, 6, 9 and 15. As 5 is already included in 15, so we have just to find the LCM of 6, 9 and 15. We find the LCM by common division method. 3 divides 6 for 2 times, 9 for 3 times and 15 for 5 times. and 2, 3 and 5 are co-prime numbers to each other. Therefore, our LCM is 3 multiplied by 2 multiplied by 3 multiplied by 5. 5 times 3 is 15. 15 times 2 is 30 and 30 times 3 is 90. So the LCM of these numbers is 90. Now we will divide 2583 by 90. 90 divides 258 for 2 times. 90 times 2 is 180. 258 minus 180 is 78. We carry 3. 90 divides 783 for 8 times. 90 times 8 is 720. On subtracting 720 from 783, we get 63. Now our answer is 90 minus 63 equal to 27. And 27 is that number which, when added to 2583, will make this number exactly divisible by 5, 6, 9 and 15. We can verify it also. 2583 plus 27 is equal to 2610. 2610 is exactly divisible by 90. The sum of the digits of 2610 is 9 and 261 is divisible by 9. Therefore, 2610 is also divisible by 90. From the given options, our answer is option A, 27. I hope you have understood the method of solving such type of questions. We go to the next question. Our question is, find the smallest number which, when reduced by 11, is exactly divisible by 16, 18, 21, 24 and 28. The given options are option A, 997, option B, 1019, option C, 1030, option D, 1008. Before solving this question, I request you to please like, share and don't forget to subscribe this channel. We have to first find the LCM of 16, 18, 21, 24 and 28. And then we have to add 11 to that LCM to get our answer. We will first find the LCM by shortcut method. The largest number in the given set of number is 28. The next number is 24. 28 is 7 multiplied by 4 and 24 is 6 multiplied by 4. So 4 is already included in this 28. We have to multiply only 6 to this. Now our next number is 21. 21 is 7 multiplied by 3. 3 is already included in 6 and 7 is already included in 28. So 21 is already included in all these numbers. Now 18. 18 is 9 multiplied by 2. 2 is already included in 28 and 9 is 3 multiplied by 3. So 1 3 is included in 6. So we have to multiply it by one more 3. So this includes 18. Now the next number is 16. 16 is 2 to the power 4. 1 4 is in 28 and 1 2 is in 6. So this is 2 to the power 3. So we have only to multiply 1 2 to it to include 16 in these products. Now this is our LCM. 28 multiplied by 6 is 168. 168 multiplied by 3 is 504 and 504 multiplied by 2 is 1008. This is that least number which is exactly divisible by 16, 18, 21, 24 and 28. Now we have to add 11 to it So this will be 1008 plus 11 is 1019. Now this number is the required number, which when divided by 16, 18, 21, 24 and 28 leaves remainder 11. So if we reduce 11 from 1019, we get 1008, which is exactly divisible by the given numbers. If you are unable to understand the shortcut method, then we can find the LCM by common division method. We write all these numbers into ascending order: 16, 18, 21, 24 and 28. Now we divide these numbers by 2. 2 divides 16 for 8 times, 18 for 9 times. We write 21 as it is, as it's not divisible by 2. 2 divides 24 for 12 times and 28 for 14 times. We further divide it by 2. 2 divides 8 for 4 times. We write 9 as it is, 21 as it is, as both these numbers are not divisible by 2. 2 divides 12 for 6 times and 14 for 7 times. We further divide it by 2. 2 divides 4 for 2 times. We write 9 as it is, 21 as it is, as both are not divisible by 2. 2 divides 6 for 3 times and we write 7 as it is, as it's also not divisible by 2. Now we divide these numbers by 3. We write 2 as it is. 3 divides 9 for 3 times, 21 for 7 times, 3 for 1 times, and we write 7 as it is. Now we divide these numbers by 7. We write 2 as it is, 3 as it is. 7 divides 7 for 1 time. We write 1 as it is, and 7 divides 7 for 1 time. Now our LCM is 2 multiplied by 2 multiplied by 2 multiplied by 3 multiplied by 7 multiplied by 2 multiplied by 3. 7 times 3 is 21. 21 times 3 is 63. 63 times 2 is 126. 126 times 2 is 252. 252 times 2 is 504. And 504 times 2 is 1008. So this is the LCM of the given numbers. Now we have to add 11 to this number to get our answer. 1008 plus 11 is 1019. This is that required number which when reduced by 11 is exactly divisible by 16, 18, 21, 24 and 28. And from the given options, our answer is option B, 1019. I hope you have understood the method of solving such type of questions. We go to the next question. Our question is, find the smallest number which when increased by 13 is exactly divisible by 24, 28, 35, 45 and 56. The given options are option A, 2507, option B, 2520, option C, 2533, option D, 2546. Before solving this question, I request you to please like, share and don't forget to subscribe this channel. We have to first find the LCM of the given numbers and then we have to subtract 13 from that LCM and that will be our answer. But prior to that, we can solve this question from the given options. On observing the given numbers, one number is 45. It means that out of the given options, when we add 13 to the given numbers, then the number must be divisible by 9 as 45 is divisible by 9. Now if we add 13 to 2507, it will become 2520, and the sum of the digit is 2 plus 5 plus 2 is 9. So option A is divisible by 9. It means that it might be our answer. Now if we add 13 to 2520, it will become 2533. 3 plus 3 is 6. 6 plus 5 is 11 plus 2 is 13, and 13 is not divisible by 9. So option B is not our answer. Now we add 13 to 2533. So it will become 2546. 2 plus 5 is 7, plus 4 is 11, plus 6 is 17. It's not divisible by 9. Now if we add 13 to 2546, it will become 2559. 2 plus 5 is 7, plus 5 is 12, plus 9 is 21, and that's not divisible by 9. It means that our answer must be option A, and without solving we can choose this option in any competitive exams. This way we can find the solution from the options. But if the options are such that we are unable to find it from the options, then we have to solve it properly. So we will learn the proper method of solving it. We find the LCM of 24, 28, 35, 45 and 56. We divide these numbers by 2. 2 divides 24 for 12 times, 28 for 14 times. We write 35 as it is, 45 as it is, and 2 divides 56 for 28 times. We again divide it by 2. 2 divides 12 for 6 times, 14 for 7 times. We write 35 as it is, we write 45 as it is, and 2 divides 28 for 14 times. We again divide it by 2. 2 divides 6 for 3 times. We write 7 as it is, we write 35 as it is, we write 45 as it is, and 2 divides 14 for 7 times. Now we divide all these numbers by 3. 3 divides 3 for 1 time. We write 7 as it is, we write 35 as it is. 3 divides 45 for 15 times, and we write 7 as it is. Now we divide these numbers by 5. We write 1 as it is, 7 as it is. 5 divides 35 for 7 times, and 5 divides 15 for 3 times, and we write 7 as it is. Now we divide these numbers by 7. We write 1 as it is, 7 divides 7 for 1 time, 7 divides 7 for 1 time. We write 3 as it is, 7 divides 7 for 1 time. Now our LCM is 2 multiplied by 2 multiplied by 2 multiplied by 3 multiplied by 5 multiplied by 7 multiplied by 3. 7 multiplied by 3 is 21. 21 times 5 is 105. 105 times 3 is 315. 315 times 2 is 630. 630 times 2 is 1260. And 1260 times 2 is 2520. And 2520 is our LCM. Now we have to subtract 13 from this number. So I write minus 13 equal to 2507. And from the given options, our answer is option A, 2507. And that is that number which, when increased by 13, is exactly divisible by all given numbers 24, 28, 35, 45 and 56. We can verify it. If we increased 2507 by 13, then it makes it 2520. And we have already calculated that 2520 is the LCM of the given numbers. I hope you have understood the method of solving such type of questions. We go to the next question. Our question is, find the greatest number of 4 digits which when divided by 10, 15, 24 and 28 leaves remainders 2, 7, 16 and 20 respectively. The given options are option A 9240, option B 9248, option C 9840, option D 9232. Before solving this question, I request you to please like, share and don't forget to subscribe this channel. The method for solving such type of question is, when we divide the number by 10, we get the remainder 2. So 10 minus 2. Again, when we divide the number by 15, the remainder is 7. And we find that 10 minus 2 is equal to 15 minus 7. And when we divide it by 24, the remainder is 16. And that is also equal to 10 minus 2 or 15 minus 7, which is actually equal to 8. Is also equal to 28 minus remainder 20 is equal to 8. So all these are equal to 8. Now we will find the LCM of the given numbers 10, 15, 24 and 28, and then we will find that greatest 4-digit number which will be divisible by the LCM of these numbers, and then we will subtract this 8 from that number, and that will be our answer. First we find the LCM of 10, 15, 24 and 28. Can we solve this question from the given options? Yes, we can solve it from the given options as well. If we add 8 to the numbers of given options, then that number must be ending with 0 because we are dividing it by 10. So if we add 8 to 9240, it will become 48, and 48 is not divisible by 10. If we add 8 to 9248, it will become 9256. It's not divisible by 10. If we add 8 to 9840, it will become 9848 and it's not divisible by 10. The only number left is option D, in which if we add 8, 9232 plus 8 is 9240, and that will be divisible by 10. So our answer must be option D. Now we solve it by our regular method. 2 divides 10 for 5 times. We write 15 as it is. 2 divides 24 for 12 times and 28 for 14 times. We further divide it by 2. We write 5 as it is, 15 as it is, as both the numbers are not divisible by 2. 2 divides 12 for 6 times and 14 for 7 times. Now we divide these numbers by 3. We write 5 as it is. 3 divides 15 for 5 times. 3 divides 6 for 2 times. And we write 7 as it is. Now we divide these numbers by 5. 5 divides 5 for 1 time. 5 divides 5 for 1 time. We write 2 as it is, 7 as it is. Now our LCM is 2 multiplied by 2, multiplied by 3, multiplied by 5, multiplied by 2, multiplied by 7. 7 times 2 is 14 times 5 is 70. 70 times 3 is 210. 210 times 2 is 420. 420 times 2 is 840. So our LCM is 840. The greatest 4-digit number is 9999. We divide this number by 840. 840 divides 999 for one time. On subtracting 840 from 999, we get 159. We carry 9. Again it divides for one time. 9 minus 0 is 9. 9 minus 4 is 5. And 15 minus 8 is 7. So we have to subtract 759 from 9,999 and we get the number 9,240. Now we have to subtract 8 from it and that will be our answer. 9,240 minus 8 is 9,232. And from the given options, our answer is option D, 9,232. I hope you have understood the method of solving such type of questions. We go to the next question. Our question is, find the least number of 5 digits which when divided by 48, 64 and 72 leaves remainder 13 in each case. The given options are option A, 10,013, option B, 10,304, option C, 10,381, option D, 10,368. Before solving this question, I request you to please like, share and don't forget to subscribe this channel. We will first find the LCM of 48, 64 and 72. Then we will divide the least 5-digit number which is 10,000 by that LCM, and then we will subtract the remainder from 10,000 and then we will add LCM to that, which will give us the least 5 digits number divisible by 48, 64 and 72. Now we will add 13 to it. That will be our answer, because if we add 13, then on dividing by these numbers we will be getting the remainder 13. We can also solve it from given options. Our one number is 72, which is multiple of 9. If we subtract 13 from given options and if that number is divisible by 9, then that might be our answer. And if that is the only number, then that will be our answer. From option A, if we subtract 13, then it will be 10,000. And 10,000 is not divisible by 9 because the sum of digit is 1 and it's not 9. If we subtract 13 from 10,304, we get 10,291. And the sum of digit is 1 plus 2 is 3, plus 9 is 12, plus 1 is 13. That's not divisible by 9. So option B is not our answer. Option C is 10,381. If we subtract 13 from it, it is 10,368. And the sum of digit is 1 plus 3 is 4. 4 plus 6 is 10. 10 plus 8 is 18. And this number is divisible by 9. So the option C might be our answer. Now we will check option D. If we subtract 13 from 10,368, we get 10,355. And the sum of digit is 1 plus 3 is 4, plus 5 is 9, plus 5 is 14. And this number is not divisible by 9. Therefore, our answer must be option C. So without solving this question in any competitive exam, we can directly select option C to get our answer and we can save our time. Now we will formally solve this question by proper method. As all the numbers are divisible by 8, we can directly divide it by 8. 8 divides 48 for 6 times, 64 for 8 times and 72 for 9 times. We can take this step only if all the numbers are divisible by the large number. here the large number is 8. Otherwise we start with 2, then we go for 3 and then other numbers. Now still two numbers are there which are divisible by 2. So we will divide it by 2. 2 times 3 is 6 and 2 times 4 is 8. And we carry 9 as it is. Now 3 and 9 are divisible by 3. So we divide it by 3. 3 divides 3 for one time. We carry 4 as it is. And 3 divides 9 for 3 times. Now our LCM is 8 multiplied by 2 multiplied by 3 multiplied by 4 multiplied by 3. 3 times 4 is 12. 12 times 3 is 36. 36 times 2 is 72. And 72 times 8 is 576. Now the least 5-digit number is 10,000. We divide 10,000 by 576. 576 divides 1000 for one time. 1000 minus 576 is 424. We carry 1 0 from above. 576 divides 4240 for 7 times. 7 times 576 is 4032. On subtracting 4032 from 4240, we get 208. Now our answer is 10,000 plus 576 minus 208. This is equal to 10,368. Now we have to add 13 to it, because this number 10,368 is that number which is exactly divisible by 40, 64 and 72. And for getting 13 as remainder in each case, we have to add 13 to it. So we add 13 to 10,368 and this is equal to 10,381. And from the given options, our answer is option C, 10,381. I hope you have understood the method of solving such type of questions. We go to the next question. Our question is, find the least number of 6 digits exactly divisible by 15, 24 and 32. The given options are option A 100280, option B 100480, option C 100360, option D 100320. Before solving this question, I request you to please like, share and don't forget to subscribe this channel. We can solve this question from the given options. As one of the number is 15 and if the given numbers are multiple of 15, then they must be ending with 0 or 5. So all the numbers are ending with 0. So we cannot find our answer directly from this property. Now each number must be divisible by 4, as 24 and 32 both are divisible by 4. So last two digits 80 in A, 80 in B, 60 in C and 20 in D all are divisible by 4. Now 15 consists 3 and 24 also consists 3. So the number must be divisible by 3 as well. So we find the sum of the digits. In option A, the sum of the digits is 1 plus 2 is 3, 3 plus 8 is 11. This is not divisible by 3. In option B, 1 plus 4 is 5, plus 8 is 13. This is not divisible by 3. In option C, 1 plus 3 is 4, 4 plus 6 is 10. This is also not divisible by 3. And the only option left is option D. That might be our answer. But we check it with the sum of the digits. 1 plus 3 is 4, 4 plus 2 is 6 and 6 is divisible by 3. It means that our answer must be option D. And if we find the answer like this, then we have not to solve the question, and in competitive exam we can directly select this option and go ahead. But if there are more than one options satisfying the given conditions, then we have to actually solve it. So we'll solve this question by regular method. We'll find the LCM of 15, 24 and 32. 15, 24, 32. We directly divide 24 and 32 by 8. We write 15 as it is. 8 times 3 is 24 and 8 times 4 is 32. Now we divide 15 and 3 by 3. 3 divides 15 for 5 times and 3 for 1 time, and we carry 4 as it is. Now 5 and 4 are co-prime numbers, so we can find the LCM now. LCM equal to 8 multiplied by 3 multiplied by 5 multiplied by 4. 8 times 3 is 24. 24 times 5 is 120. 120 times 4 is 480. So our LCM is 480. The least 6-digit number is 100000 is our least 6-digit number. This is 100,000. Now we divide it by 480. 480 divides 1000 for 2 times. 480 times 2 is 960. On subtracting 960 from 1000, we get 40. We carry 0. 400 is not divisible by 480. So we carry one more 0 and put 0 in the quotient. 480 divides 4000 for 8 times. 8 times 0 is 0. 8 times 8 is 64. We write 4 and carry 6. 8 times 4 is 32 plus 6 is 38. On subtracting 3840 from 4000, the remainder is 160. Now we subtract 160 and we add 480 to get our answer. 480 minus 160 is 320, and 100,000 plus 320 is 100,320. And from the given options, our answer is option D, 100,320. I hope you have understood the method of solving such type of questions. We go to the next question. Our question is, find the greatest number of 5 digits which when divided by 15, 18, 24 and 28 leaves remainder 4, 7, 13 and 17 respectively. The given options are option A, 99,989, option B, 98,779, option C, 98,269, option D, 98,959. Before solving this question, I request you to please like, share and don't forget to subscribe this channel. We try to solve this question from the given options. On observing, we find that the number minus the remainder in each case is same. 15 minus 4 is 11, 18 minus 7 is 11, 24 minus 13 is 11 and 28 minus 17 is 11. So if we add 11, then the number must be divisible by 4 as well as by 3, and it should be ending with 0. So on adding 11, every number is ending with 0 because it should end with 0 or 5 because the number must be multiple of 15. So it should end with 5 or 0. Now if we add 11 to the option A, then 89 plus 11 is 100 and 999 are divisible by 3, and then the last 3 digit 100 is not divisible by 3. So option A is not possible. option B. In option B, if we add 11 to last two digits, so it becomes 90. So number will become 98790, and last two digits are not divisible by 4. So option B cannot be our answer. In option C, if we add 11 to 69, it will become 80. 80 is divisible by 4. Now we will find the divisibility by 3. So 9 plus 8 is 17, plus 2 is 19, plus 8 is 27. So option C might be our answer. Now in option D, if we add 11 to 59, the last two digits of the number, then the number becomes 70, and this number is not divisible by 4, so it cannot be our answer. So the only option left is option C, and that must be our answer. Now we solve it by regular method. We will subtract the remainder from the given numbers. When we divide the number by 15, the remainder is 4. So we write 15 minus 4, this is 11. When we divide the number by 18, the remainder is 7. This is also equal to 11. Then when we divide it by 24, the remainder is 13. 24 minus 13 is 11. And when we divide the number by 28, the remainder is 17. And 28 minus 17 is also 11. So this is equal to 11. Now we will find the LCM of 15, 18, 24 and 28 by common division method. We divide these numbers by 2. We write 15 as it is, as it's not divisible by 2. 2 divides 18 for 9 times, 24 for 12 times, 28 for 14 times. Now we again divide it by 2. We write 15 as it is. We write 9 as it is. 2 divides 12 for 6 times and 14 for 7 times. Now no two numbers are divisible by 2. We divide these numbers by 3. 3 divides 15 for 5 times, 9 for 3 times, 6 for 2 times, and we write 7 as it is. Now 5, 3, 2, 7 are all co-prime numbers. So our LCM is 2 multiplied by 2 multiplied by 3 multiplied by 5 multiplied by 3 multiplied by 2 multiplied by 7. We have 1 5 and 1 2, that will make 10. So after leaving this two digits, we will multiply all other digits. 7 multiplied by 2 is 14. 14 times 3 is 42. 42 times 3 is 126. 126 times 2 is 252. And we put 1 0 to it. So it will be 2520. This is our LCM of 15, 18, 24 and 28. Now we'll divide greatest 5-digit number by 2520. The greatest 5-digit number is 99,999. We divide it by 2520. We take the first 4 digits, 9,999. 2520 divide it for 3 times. 3 times 2520 is 7560. On subtracting, we get 9 minus 0 is 9, 9 minus 6 is 3, 9 minus 5 is 4, and 9 minus 7 is 2. We carry 9. 2520 divides 24,399 for 8 times. 2520 times 8 is 22,680. On subtracting 22,680 from 24,399, we get 1,719. Now we subtract 1719 from 99,999. On subtracting 1719 from 99,999, we get 98,280. Now we have to further subtract 11 from it and we get 98,269. This is our answer. And from the given options, our answer is option C, 98,269. I hope you have understood both the methods of solving this question. One is regular method and the other is from given options. Please do lot of practice from different books and solve as many questions as possible of quantitative aptitude. Here completes this video. Please like, share and subscribe to this channel and don't forget to press the bell icon to get the latest notifications. Thanks for watching.